Hello and welcome. My name is Patty Murray and I will be your host and moderator for today's Food Safety Tech webinar, How to Avoid Disaster from Undetected Material Variability, featuring Mark Carter, owner of MC Squared Enterprises, who will discuss why testing equals quality assurance, Bill Bremer, principal and owner of Kestrel Management, who will be speaking about testing conformance, and John McGlynn, vice president of EM&S, who will be making some introductory comments. Today's webinar is being hosted by Food Safety Tech and sponsored by EM&S, the provider of GSQA, Global Supplier Quality Assurance, the first web-based system that reaches to all corners of your supply chain. For over 13 years, EM&S has been a leading provider of software as a service supply chain quality solutions used in 70 countries and many Fortune 1000 companies. Now let me tell you about our speakers. Mark Carter is owner of MC Squared Enterprises, an independent consulting firm with a focus on technology development, evaluation, acquisition, and application for companies serving public health. Mark's 20-plus years of industry experience include serving as CEO of QC Laboratories, corporate vice president of R&D at Silica Group Corporation, and section manager for microbiology and food safety at Kraft Foods. Bill Bremer is principal and owner of Kestrel Management. Bill is a seasoned food industry practitioner and has worked in manufacturing and distribution operations for over 30 years. He leads Kestrel's food safety consulting group focusing on safety quality, certification, compliance, operational effectiveness, planning, and strategy. Bill is experienced in major GFSI standards and is a working group participant in new standards. John McGlynn is vice president with EM&S. The company's supply chain quality management system, Global Supply Quality Assurance, GSQA, is used by food, beverage, chemical, consumer products, and advanced manufacturing businesses with facilities and suppliers in 70 countries. John has 30-plus years experience with quality systems, supply chain management, ERP, computer-aided design manufacturing, and digital mapping. After our speakers give their presentations, you will have the opportunity to ask them questions during a special Q&A session. And I encourage you throughout the event to actually send in your questions using the Q&A feature. So now let's get started, and I will switch control over to John McGlynn. John?
Okay. Thanks, Patty. I'm going to share a presentation. And hopefully that's in full screen mode. You all can see it?
Yes.
Okay, good. Thanks for joining us today. I'll add my appreciation. We've got a mixed audience of folks from food and beverage, chemicals, discrete manufacturing, and renewable energy. Our focus today is on material variability across industries. Food references will be made because it's, it's a commodity we all have in common, and new legal responsibilities in the food biz are the trend of the future for other industries whenever market safety is concerned. Okay, manufacturing. Whoops, how'd that get in there? Vive la différence, right? As a saying, it's a wonderful celebration of variety, but it's not a good thing in manufacturing. Material variability. Okay, we know all materials vary in important characteristics by lot, version, shipment, season, supplier, plant, ship, production line, and expiry date. And that can span from, let's say, apples to high-tech equipment. Or we can say materials are always varying. Across industries, materials vary for many reasons, but mainly because it's tough to make stuff consistently. Whether it's apples for apple pie or wings for high-performance aircraft, producing the same material the same way, day in and day out, is a challenge. Often can be problematic to the manufacturing people in the audience. They know that. And in extreme cases, a disaster. If lucky, the company pays in wasted money. But in some cases, customers are hurt or worse. Sounds like something that should be managed to us, and most likely to you as participants on this webinar, whose job it is to minimize material variability. Okay, there are plenty of reasons for this, but this is the scary one right here, where counterfeit and contaminated materials are entering supply chains. And the bad news about this particular publication is that this trend is on the rise. That's the dark side for sure. Bad people do bad things, and it's gaining on us. Now, to make this even personal, the three of us were at a Food Safety Summit last year, a food conference, and we all got sick. 216 people got sick from food at a food safety conference. So it just gets personal after a while, and for some people, of course, it's catastrophic. Now, if we switch gears out of food and we go into consumer products, you know, Lulu and their whole effort to fend off this recall ended up costing them $67 million to get rid of all that bad pants, and then their valuation dropped by $2 billion. I mean, you know, what can we possibly say? My comment is, was the transparency scope broken that day, or did the company not care to even have a look at the product they were selling and its quality? So, you know, some situations are simpler than others. Let's take bread. Simple, right? Let's blow up that bill of materials and look at the label. 40 different ingredients. Do you really think they were all QA validated in their supply chains before being incorporated in this finished product? Does that look familiar? Maybe in your facilities? And don't we all feel sorry for this person as they try to get through the material validation process with specifications and receipt and supplier assurances? Another view is from the pharma business. This is directly from Wikipedia, and it's worth reading. It's logic. It would be acceptable to consider that raw materials used in manufactured pharmaceutical products can vary in their attributes, moisture content, crystal structure, et cetera. It would also be acceptable to consider that manufacturing equipment does not always operate in exactly the same fashion due to the inherent tolerance of the equipment and its components. It is therefore logical to say that variability in raw materials married with a static batch process with inherent variability in process equipment produces variable product. I mean, that's kind of like undeniable. Now, if we mix in a little bit of science from the American Production and Inventory Control Society, the law of variability, as published, it got my attention anyway, in Strategic Finance in October, What's Wrong with Supply Chain Metrics. The law of variability states the more that variability exists in a process, the less productive that process will be. Now, in my words, that means the more adjustments production has to do for these variances, that lowers optimization and drives up costs. Now, more quoting from that particular publication, the war on variability has been waged for decades. That's an interesting characterization, wouldn't you say, the war on variability? And the point of this particular paragraph is that it's not just a local issue, it's across the system. And they published this particular chart that says as time goes on and processes, in fact, accumulate across the production of a final product from production events, pre-production events, external suppliers, and raw material suppliers, the variability can, in fact, start to accumulate. Now, the tricky part of this is intuitively we make this common mistake. You know, first supplier, they're not so great, but, you know, a second-tier supplier does a pretty good job. Heck, our plants do a great job. So it averages out about 96%. We're doing pretty good. When, in fact, probability is calculated by multiplying the percentages. We're really talking about 87%. And that's why Six Sigma performance is so difficult to achieve. It takes a real concentration on all those factors. And that's where that whiplash comes in. The variability starts to go up, and the reliability goes down, and it gets out of control. And finished product testing sometimes cannot reveal all of those issues. So why do we worry about this? Well, what the heck? Market safety and, oh yeah, product success. As we know, some of these characteristics are product safety related, and we're pretty familiar with those. Some are quality related, have to do with characteristics, and some are performance related. But they all need constant surveillance for continued market success. And then we have new materials, changes in business conditions, new competitors, meaning new products. They all contribute to reasons for change and the resulting variability in plants. And the bottom line of that then is recalls prove that belief-based confidence is insufficient today for continued market success. You've got to have data. You've got to have real data because it drives awareness. It gives you visibility. And data validates specification conformance and material performance for consistent quality assurance. And the reason we're having this presentation is how can you do that effectively? And so we recommend you do tests. You test for material variability and you record the results in a statistical approach. We know the materials vary in all important characteristics by lot. We've been through that. But it's too much work and too much effort to test everything for material variations. You have to decide on important characteristics. And then you'll notice when you track them, they tend to vary over time, from production line to production line, from plant to plant, based on component or ingredient material characteristics. We know it's based on production skills for sure. And you know what? It's based on everything else. Materials vary. And kind of sum up my thoughts, is variability, I probably should have put that in quotes, simply a point of view, or is there some yardstick that makes materials that they should measure up to? And with that, I really want to segue then to Mark to tell us what's the way that professionals, manage variability. Okay, Mark?
Thanks, John. So next, with that lead in, I'd like to give us the opportunity to go ahead and take a look at some of the things that create challenges with material testing variability. So my portion of this is going to talk about supporting supply chain excellence through testing. A lot of times in my career, I felt like testing regimens have been more or less exactly like this cartoon, where they were pulled out of a hat. No one really knew exactly why they were put together, and no one understood exactly what the outcomes were going to be from the testing itself. But when we look at these and we think more back to where we talk about control and measuring variability, you can think about W.A. Shewhart, the father of the control chart, and a statement that he made that goes, an element of chance enters into every measurement. Hence, every set of measurements is inherently a sample of certain, more or less unknown conditions. And even in those few instances where we do believe that the objective is really being measured as a constant, the measurement of this constant are influenced by chance or unknown causes. And this leads back to what John said, discussing the variability itself. We don't know where the variability comes from, but we understand that it's there. But the only way that you understand it and begin to understand it and make improvement is through measurement. So when we talk about an overview of the value chain, we understand that the value chain is very complex. And how's testing going to help us understand it? We can address and characterize the value chain through all different stages of product development, product life, all the way from raw ingredients or raw materials that are used to make things like packaging, all the way through the production of food itself. Testing generates in-depth knowledge that will help you understand that supply chain. And you want to use measurement to help you get better. I don't think there's anything we do in our lives, even from the simple thing of going to the gym and working out or looking at anything, where we don't have some standard of measurement where we say either we want to get better or we want to do something differently, and we do that totally intuitively without taking some type of measurement. A key issue is that the regulatory climate across the board is changing. FDA has more authority than previously before. FSMA has given them this in the food world, but we also see it extended other places where the regulatory climate is more consumer focused. I think there's more pressure on companies to deliver products that are consumer friendly and that they've done their own due diligence. But the bottom line on the way to look at this is that anything that deals with regulatory testing is a baseline. And testing itself, if you're going to understand what goes on with a product, understand variability, understand safety and the characteristics that go with those products, you have to do other types of testing that extend beyond the regulatory baseline. So let's discuss the test spectrum briefly. And when we think about this, when we say safety, an example would be food safety testing for packaging or for pathogens, Things like burst strength, defects in parachutes, metal hardness, detecting brittleness. These are all regulated standards normally within an industry, and they're required to be done, and they're normally performed on a regular basis. The expense of doing those could be high depending on volume, but normally they're not that expensive of a test to perform. Then on the base level, it's assumed of safety. We go to quality itself, where we look at dimensions. These are customer demanded characteristics. At times it can be looked at to add value, and it could be unique to a client. The last is actually performance. How does a material perform in a process? And these are the higher level tests that are done. For instance, you want to know how something flows at a certain temperature, or how to set it up when it's being cured. This could be something that definitely deals and changes based on small differences in materials. And the only way you understand those, or understand the failure of a product or the success of a product, is to accurately measure those, record the data, and then use that data to help improve the process. But every business sits back and goes, okay, this is great, but we've got challenges to understand. What does it take to test? You say to yourself, do I have enough people to even sample what needs to be sampled? When we build this big plan, how do we administer it? Who's going to do what? Who's responsible for what? You ask yourself, how do I communicate the changes in my needs to suppliers? And then how do you communicate value to management? That's going to be a big question that we're going to try to answer. Bottom line that everybody talks about, and the bottom line always talks, is how much will this testing cost me? What's the value of it to our clients, and the impact that it's going to have on the regimen that we're applying to the product? The bottom line on that is, many times we've seen where testing isn't optimized for what we're trying to accomplish. We often have times where people do many more tests than need to be done, or don't do enough in an area that could give them more value. And that's something critical to understand. When we talk about material testing challenges themselves, one of those things that we look at is, how do you perform a risk assessment to understand how to develop criteria for testing? You could do economic studies to understand the impact of testing itself, both internally in your own company with your suppliers, or with the people that you sell those items to. And then we look at conformance to international quality and safety standards as being a challenge. Are we harmonized on the testing methods that are being done? Do we look at the validation and verification of sampling and testing as an issue? These are areas that when we go and say we need to do a test, some areas very much have things codified. Other areas, it's more freewheeling, and especially when you start to talk about some of the higher level tests where you're understanding performance. It's also very important to understand the cost of quality that we're talking about too. What does it take to make a quality product and maintain it? As we look at other factors now, we talk more about things that deal with, an analyst performance, laboratory performance, and then method selection. These add more of the human side, not so much from the manufacturing side, but the human side where it's more mechanical. What are the things that make a difference on the testing regimens that we're talking about? And again, these three factors now are kind of where the rubber meets the road, and you get material variances based on what you're doing to test them themselves. Again, this leads back to, or goes back to what John said earlier about variation and our understanding of the characteristics of a product becoming more and more important as we move along, and also that variability increasing as we move along. So if we talk about where in the value chain does testing occur, many times raw materials of all types. These could be screws, bolts, they could be paper, packaging material, it could be food products. A lot of times things are tested before pre-shipment. You have manufacturer receipt, or then certificates of analysis and other things are screened and verified. Many times in a plant pre-conversion where something's being changed from one thing to another. You also look at in-process testing, and then many times finished product before you have a B2B transaction or something goes out to a consumer where things would be tested. Then there's verification testing also, where you could talk about looking at the formulation itself and the performance of the product, and not just the intrinsic characteristics that describe the product's physical or other types of characteristics. Here's a quick example to look at And it's a dairy chain to think about all the areas where testing can occur, where things are critical and things are being converted or moved or manufactured, where you would say, okay, now we have product A, and product A, or raw ingredient A, has moved in a tanker, gone into a plant, been pasteurized, and every time it becomes something different. And with every move, with every time it's put into a package, the packaging material itself could be tested. The tankers could be tested. The environment within the plant itself could be tested. So there's multiple opportunities for testing to occur and for you to understand how a product may have gained variability or how it may change from one step to another in the value chain. So how do we normally determine what test are we even going to do at all? And I think in industry and many other places, we look at specification verification that drives testing. Where do those specifications come from? Many times we don't know, but many of the tests are not safety related, but still base regulatory needs must be met. A lot of times we have agreements that are formed between suppliers and purchasers that give you the opportunity to say, this is what we want to buy from you, and it should look like this. This is where we put those physical characteristics in, and oftentimes those test regimens are there. Those regimens many times includes physical, chemical, and microbiological tests if needed, and the methods are described in many different places by FDA, USDA, AOAC, ISO, NRC, DOD, etc. EPA is another area where many tests are prescribed for what could be going into a marketplace. But the idea is that it's an ecosystem of testing and specifications and needs that all come together to describe a product that could then become more variable, and that we need to understand where that variability comes from. What about specifications themselves? When we talk about it normally, they're required for all components of a food process, but I've worked in industry a long time, and I've never seen a place where you bought any component of anything that didn't have a specification attached. I think they're one of the most important portions of any type of transaction in commerce where you're moving something from one person to another or one group to another, and you need to understand what it is. It's a standard of identity, or either it tells you about performance, right? And the specs themselves end up measuring quality, safety, or performance, and the universe is kind of built around those parameters. And like I said before, they're usually all types of tests: chemical, physical, microbiological, taste, smell, organoleptic tests that go along with understanding what's going on with those products, and then how they're going to react in the marketplace. Well, after you've determined that, then the next thing you have to say is we've got a specification, we know what test we're supposed to do, but what's the purpose of the test itself? Why are we doing this? And if you think about it, most likely we're testing to distinguish good from bad as a basic need. A lot of time we look at lots of goods, pieces. Maybe we want to determine process changes, and that's why we're testing, to make sure that there's a given parameter that if we measure this, we know that a certain product was, for example, manufactured at a certain temperature for a certain time. Therefore, it has a certain hardness, a certain amount of flexibility, a certain viscosity. We want to also maybe determine if a process is approaching control limits. So we're measuring a process itself and looking at the product that comes out of it. Then simply we may want to do what we all do a lot of times, and that's just rate product quality for that given time to say, yes, this is acceptable to use. And again, I think the highest level that we want to understand at some point is to actually understand that product's performance and the process that we're going to put it into with the way that it's going to be used. Is it fit for the purpose that we're going to use it for? Here's some more reasons to think about what's a test purpose. Is, we can look at determine inspection accuracy, check the precision of measuring instrumentation, right? The key is also to acquire product design information and, again, measure process capability. Those are other areas where, again, higher level where we talk about measurement and testing. But again, if they are not done, if we don't understand what they mean to the overall process, not doing these things correctly, not doing any of them, or doing bits and pieces of them, but again, not understanding how to pull that together for testing purposes can be disastrous. What do we talk about for potential test frequency, for instance. How often should we do some of the tests that we do? And the list that I have here are things of ways we look at that you can determine potential test frequencies. And I think in industry we've seen testing regimens that are driven by risk, by specifications themselves, for instance, by a purchasing contract, company policy, and then simply with regulatory compliance. And I think, you know, a good example that I've seen from my experiences have been where you have mandated frequencies for testing by, you know, FSIS, USDA. I've seen mandated frequencies to be given by EPA. But again, it's the potential for how much you're going to test, when you're going to test it, where you're going to test it, and again, understanding why. So if we talk about what are we even measuring, normally there's 4 scales, the nominal, ordinal, an interval, and a ratio. We want them to have a relationship to some property of that product that we're measuring, either it being indirect or direct. But it gives us some information about those earlier areas that we talked about. We want to understand the production process, you know, sampling all the way through making a decision finally about that product and the safety of it. And again, you want to understand the performance of the product itself. And again, when I say product, this could be anything that we talk about from a material variance standpoint, but you want to understand how rugged a product is. Is it practical for you to use it in your process, or to manufacture what you need, or to use it, again, for packaging your product? You know, are the characteristics described specifically? And are your tests reliable? Do the things you're testing and the characteristics you're talking about reliably describe the product? I can think of many times from my own experience where we talk about performance characteristics and you try to find practical test regimens, and at times it's difficult. It's very hard to find things that are specific, that meet every one of these characteristics from a testing standpoint, but the idea is to find something that gives you good information about the product, that makes you confident when there's a change in that product that's significant, that you'll be able to see it. When we talk about measurement considerations themselves, we want to understand that the unit reflects variation, and this, again, how granular do you need it to be to make sure you're testing and understanding changes? Is it consistent over time? Is it unbiased? Do we find that it characterizes product relative to the specification limits? And again, in commerce, this is extremely important. We want to reflect product also that has not been measured, right? So again, we're not going to measure every product that comes through. We normally have a sampling plan. We have tests that are listed, and we want to make sure that the measurement that we're using reflects not just what we have in our hand, but what's in the rest of the lot that we bought. We also I think it's very important for people to think very hard about how you manage test data across an enterprise, and this also includes places where you could have co-manufacturing interactions and then the interaction with your suppliers. Testing for itself, putting the data in a drawer, not managing it and relating it to other parts of your process. May be good if you want to take a snapshot and understand what happens for a day, but for true quality improvement and for true measurement improvement, you have to understand the data and then relate that to the people that you're working with to create the best situation for the products that you're making and for your clients and the consumers themselves. Again, we talked earlier, these are just some more examples where we say that your measurement considerations want to be able to take, I think the biggest point on this page, say technique comparisons, right? We want to make sure that if there's a difference in the way things are measured, that we understand it. The product information from measurement that can be used to make in-depth decisions is accurately being captured, and those measurements are being used in a way, again, that we talked about earlier, to manage the data, to manage the process, to help improve your business, again, because the optimization of testing can save you great deals of money if you understand and do exactly what you're supposed to do, and you find out what's the most efficient way and the most valuable way to test. And then one of the final things, as we get closer to the end of my portion of the presentation, I want to talk about is, again, everything needs to be statistically based and validated. We need to understand exactly what's the value going to be of what we're doing? And then the statistics have to bear through such that we understand exactly what's going on with the measurement process itself. We want to understand the standard deviations. How repeatable are we at doing the test? What's the reproducibility like? And then the human factor comes in for operator bias, operator error, and then the bias in the test itself with the way it's designed. We've seen this anywhere from metrology that can be applied to measuring things, all the way through genetic testing for pathogens in food. All of these applications and all of these characteristics and areas apply to understanding the statistical performance of the test itself. So in summary, I'd like to say that I feel that testing is just necessary to understand the condition, quality, and performance of a material. And you just can't get away from that. And then assuring safety is a base requirement of the things that we do. But again, companies need to create significant value by measuring more than safety attributes. And you have to look at higher levels of understanding that come from focused testing regimens and data mining. So with that, I'd like to now turn the webinar over to Bill for him to talk through a higher level and some more specific examples of material testing.
Thank you, Mark, and thank you, everyone. I'm glad to be on the webinar today. I'm going to talk about variation of product through the receipt process, through the customer-supplier relationship side of things, and specifically to food, but it carries over to some of the other areas that we talked about earlier that John touched on with variation. One of the things that's going on is there is a lot of emphasis on the food supply chain. So within the food supply management area of the food industry, it's a key area of conformance and compliance that must be met. Historically, this area, the receipt of food-grade materials to specification, was one of the leading nonconformances to FDA. Ultimately, it needs to be risk-based. Proof requirements are an imperative. They have to be met 100% of the time, all the time. Very difficult to do, and not always done. Foreign supplier verification of goods is another requirement. This could lead into some of the slides that were shown with regard to food fraud and things like that, or fraud in general. And then it's becoming much more difficult or much more important for Tier 2 suppliers and lower to comply. So there's a vulnerability there. There's a push down of a higher level of integrity in both specifications and product quality. And when you have deviations, that's one of the variation issues to be concerned about. Ultimately, processors and distributors must provide evidence of the testing of the materials they're providing, approval of the food ingredients and the materials. Past established supplier qualifications were based on a lot of informal relationships. Established practices continued due to a lack of identified variation. It wasn't being measured or found. It was assumed to be good. Relationship was based on ongoing qualification of meeting service requirements. So things like how good was the product specification and what variation was there was not really addressed all the time. Industry allowed suppliers to be approved through grandfathering. So it wasn't uncommon. We've approved these suppliers because we've been doing business with them for many years and we've never had any issues. And then updates were not always closely monitored. But those are not critical, similar to some of the things with specifications that John talked about and Mark discussed as well. There's variation just in the whole specification world without, concern to the product quality. So the focus of maintaining integrity for the supply of food product and materials was limited to really the receipt approval. Critical data was commonly missed or wasn't included, and it certainly presented a risk when it came to the condition of, for example, bulk commodities. In recent times, the food safety requirements have been evolving with much more emphasis on suppliers and specification management. Both these are critical. And this pushes corporate food safety requirements from the primary food producer to their Tier 1 suppliers and their Tier 2 suppliers, and even lower, to where companies were never really asked before, depending on what ingredient or material they were providing. This has resulted in the need for a lower supply chain management of specification level down into the supply chain, including transaction level records, multi-year data, and data integrity. The information isn't good unless the data is correct. Previous, this level of discipline was not fully supported at all levels. It just wasn't requested when you got down to some of the materials that now have to comply. Now food ingredients has been expanded to all materials that always weren't within the realm of food. Packaging, contact materials, grass ingredients, fillers, and the like. Market changes and FSMA have led to the expansion of certified food product to be supplied from qualified suppliers. Formal practices on each side of the supply chain, customer and supplier, must be met, including things like product lifecycle management, having the correct forms completed, records, monitoring, data. Although this is required, it does not always occur. So previously, the focus on the update of food safety in the U.S. and Europe was evolving at the same time. If you go back 20 years, 15 years, this area started getting legs for various reasons. So in the mid-2000s, the FDA commenced with studies to require food companies to update GMPs to CGMPs and some other areas as well. This was all under development. It's evolved into some of the current legislation. The needs for hazard analysis was also established in food areas where it hadn't been required before. And up until the passage of the Food Safety Modernization Act in 2011, there were significant outbreaks that were occurring, and they still continue. The law was signed into effect early in 2011. It's been evolving since, and will go into practice for the most part later on this year. Earlier in the 2000s, in the European Union countries, there was a movement to create the Global Food Safety Initiative by the Consumer Goods Forum. This was led by industry to ensure conforming food in Europe with the formation of the EU. The U.S. companies felt that this was the right approach to take, and many of the leading U.S. companies joined the GFSI in about 2005 as significant outbreaks continued in the U.S. The issue in the U.S. was brought about due to concerns through public surveys and government statistics that listed food safety as one of the major concerns of the U.S. population. So from disasters to the current state of the food safety supply chain, it's moved to a heavy emphasis on industry, the supply chain itself, and regulatory compliance. Each of these areas are similar, but they different oversight. A consistency is that there is a greater emphasis on the integrity of food ingredient supply than ever before. This includes, as I mentioned before, any contact materials, packaging, generally recognized as safe materials, and services like logistics, where the quality of the food and the specification of the food is dependent on the service being provided. So all require identification, traceability, proper handling, and the receipt to specifications. Before you accept something, you should know that it's food safe. Otherwise, it should be rejected. A nonconformance to specification must be validated and verified for all materials for use in production without variation. So each receipt is requiring monitoring of the food products, and it must be evident that the process related to that particular food product works to provide safe food. This is a spectrum of risk, and basically what this shows is your risks will go up if your costs and investment are not there. So the upper line shows what happens when emphasis and investment is not made to ensure against variation and safe food. And basically it starts with the product performance and the customer acquisition. It goes through the quality and the customer retention, and then it ultimately ends up the product safety and the legal compliance. The little picture at the top, well, that's a man behind bars or a person behind bars. And the note is that 3 PCA defendants were found guilty on a total of 98 federal felony counts, the owner, the sales broker, and the quality manager, for the outcome of highly variable food being released to the marketplace that resulted in death and injury. The bottom line shows the cost elements, as costs will go up if investment is not there. And really, when the investment is not there, you're in a reactive mode, a variable mode, really. While if you do invest in food safety and reduction of variability, your risks will go down, and it's a proactive situation. The current compliance and conformance situation is that the attention on food products and materials to spec requirements requires accuracy, not emphasized or provided as much in the past, and this needs to change. All levels of specification compliance is critical to ensure supplied products be verified to avoid variation to spec and potential disaster. Typically when there's variation, much of it is on the bad side and very little of it's on the good side from a product standpoint. The most common method at the transaction level is C of A's and C of C's. These require discipline and accuracy, and they must be maintained and they must be provided. Information must be applied, managed, recorded to ensure against breaches in food safety at all levels. So practices must be effective, as the original statistics for the Food Safety Modernization Act is 5,000 deaths annually, 276,000 illnesses, and many unknown reportable situations, as well as permanent impacts and injuries. So this is very, very serious when we take a look at the overall scope of product risk, whether it's food or anything else. In the market, the food industry is very old and antiquated, and there are a few practices fully support the availability to validate and verify practices through documentation in an effective way. It's not well supported by conventional IT, information technology. EMNS's GSQA provides a proven validation system to prevent against variation and food safety concerns. This option provides functionality for monitoring and verification that processes meet requirements to prevent a disaster and prove compliance. Specific focus provides integrity and specification information records in a closed loop of product condition through the supply chain. Control is absolutely necessary for compliance and accurate information and records described for food safety compliance and company specifications. FDA and FSMA require complete traceability, or a company will be subjected to probable cause of non-compliant product. GFSI fully requires the control of product specifications within the supply chain. Those without records cannot prove they are in compliance, so the records are eminently important. And the lack of control systems and records put companies at risk for food safety disasters, compliance, the value of their inventory, regulatory nonconformances, and a significant amount of business risk. GSQA by EMNS provides the traceability and monitoring of approved food materials to support all products against variation and ultimately unsafe food, which is our goal. GSQA also, this is the food safety loop by the FDA for FSMA, and basically if you follow this, the GSQA system provides this: record keeping, tracking hazard analysis, preventative controls, establishment of monitoring procedures, ensuring corrective actions, verification that the system is working, and back to record keeping. So on that note, I'm going to turn it over to John to bring us home.
Okay.
Okay, well, thank you so much, Bill. I'm inviting John and Mark to jump back in here for the Q&A session. I want to thank our speakers for their presentation, and then also encourage our attendees to continue sending in questions for our speakers, and we will get to as many of your questions as possible. Let me start with one for Mark, but Bill and John, feel free to weigh in if you would like. How do I get my management to commit to better QA by doing more testing when it costs more money?
Patty, that's the the million-dollar question, but I think what you have to do is understand what the value of the tests you're doing mean. I've seen many times that a few inexpensive tests can save millions of dollars by identifying a problem early and not creating a disastrous situation by letting non-conforming materials get into a process, whether, like I said, it be anything from raw ingredients to packaging materials to things like that. So I think it's important for people to understand the value of the test, the value of the materials that they make, ship, and also just looking at the quality system overall and what testing brings to it and how to improve it.
Bill or John, do you have any suggestions?
I'll jump in. I agree with Mark. That's a tough question. With what's going on in the food market anyhow, it's a pretty significant change where the investments and the value of businesses are based on how much money they're going to be able to put into a higher level of compliance and reduction in variation. I do fully agree, though. If it's not done, the cost and the stakes are great. So this is something they're going to have to get their hands around, and really it comes down to a justification against risk. If something goes wrong, what will that do to your business? And then if you do it right, what are you protecting with regard to the value of your business?
Yeah, and this is John. In our processes, we're always involved in some historical events where either high variation in materials or completely non-functioning, non-conforming materials get in the supply chain. What happens to plant disruptions? Does the plant ops personnel, do they make their shipments on time? To manage shipment performance, do they carry safety stock? What's the cost of safety stock if the materials flowing through the supply chain are unreliable? Those start to become the economic dimensions that help quality professionals justify this otherwise virtuous point of view that, management and senior management can look down on possibly as just being a cost center as opposed to a profit center. But if a quality person can turn those dimensions of disruptions, of scrap, of extra work, of safety stock requirements, you can turn those into expense, and they can lower that expense, and they can add to the profitability of the production facility. Now they're adding to operations performance. Instead of being a cost center for virtuous activity, they now are driving down those cost drivers that reduce profitability. So if the QA person can recast themselves along those dimensions, now the ops person is going to say, yeah, test that too, and test that. I don't want that happening in my shop anymore. And so next thing you know, the quality regimen, as Mark mentioned, expands. It gets more focused, and maybe a consultant's brought in. But at the end of the day, it saves money, and it saves the operation from wasted effort and the lower profitability.
Great. And today we talked a lot about food, but besides the food industry, what other types of regulated industries should be interested in quality? And maybe, Bill, if you could start us off.
Sure, that's a great question because there are some of the fundamental material suppliers, the chemicals, whether they be food grade or not, or chemicals that go into pharmaceutical or over-the-counter personal care items. They're under the same level of scrutiny as food, and these type of companies need to be considering the same things. Packaging would be another one. A lot of times you talk to a packaging company that has been making food packaging for many years, their first argument will be, well, we're not making food. That's changing very, very quickly. So I'd say the chemical industry, the packaging industry, and the products or ingredients that go into personal care, pharmaceutical, are under the same type of scrutiny and improvement requirement to reduce variation.
Now, I'll add a couple more comments. It's John. Some of our customer base, our customers have their customers requiring that they manage material variability in a system like GSQA. They're tired of receiving materials, be it discrete components or subassemblies or process results. they're tired of getting materials that vary so much that they work hard to adjust their production processes to accommodate those variances. So they're ones driving some of our customers. And in fact, one customer had to go back and manage a supply chain of 4 levels back in the supply chain with all the design criteria, all the test methods, all the test results, and all of the certifications of the professionals involved in this process, all online in GSQA, so that customer of theirs can stay happy that they know that this company has online all that information at a click of a button instead of the typical situation. Let me take you over to this wall of file cabinets, and let's go back through and try to create the chain of genealogy of the product we sold you last year that went bad. So the idea being that customers are now forcing companies to take a stronger, harder look at QA in their supply chain.
I have a question from Niku. How do you assure the quality of the products and the production processes of the Tier 2, that is suppliers of your suppliers, especially if your suppliers use a variety of sources and overseas manufacturers as their suppliers? Who would like to take that on?
I do, John. Do me a favor. Okay. In our miscellaneous slides, can you pull up, I think it's 38, number 38? It's a supply chain diagram. Ooh, about 41. That's it right there. Yeah. Okay, so if we take Mark's dairy supply chain and generalize it, this is what we see across every industry we deal with, okay? It is the fact there's a finished product plant supplying a distribution channel, whether it's directly B2B or it's B2C. There is a feeder plant in the organization making some sort of intermediary product, or it's a first-tier supplier, and behind them is a real external supplier, or maybe the first-tier supplier's sub-supplier. So this kind of represents the fact that there's a flow of material. Now, the only way to see all this is in a system like GSQA, where it's a single point of quality control and visibility in our system over the web. And we've been on the web forever. Our product's always been on the web, and that's the wonderful thing about the Internet. We can look across disparate companies, all with independent systems, and create a homogenized view of the movement of material and the quality characteristics from sub-supplier to supplier to finished product plant to the DC. So the idea being that this product, GSQA, allows, to answer the question, the company that licenses our product to basically enforce specification conformance at the first-tier supplier level and at the second-tier supplier level. And I'll reference back to the company that goes back down 4 levels. But for sufficiency in this diagram, let's just say you want to buy some, some sort of a gravy, let's say, to keep it in the food biz, and the gravy comes from the first-tier supplier. But you know darn well the gravy is made up of a half a dozen or 18 constituent parts, and those all come from a number of sub-suppliers. You can, in fact, in GSQA, monitor the performance of the materials characteristics at the sub-supplier for salt and sugar and barley and other additives, whatever goes into that gravy, so that the gravy materials that come into the first-tier supplier are then manufactured into the gravy with a spec that you've produced as well. So that's the magic in GSQA, is you're able then to distribute specifications across the supply chain pertinent to each activity at that point in the supply chain, not burdening anybody with all that spec conformance chore. It's all parsed into the location where the data is collected and spread across the supply chain so everybody contributes. And by the way, I'll just go on just one more minute. At the end of the day, GSQA can produce a product genealogy, as-built bill of material by lot number and by serial number, specifically across that supply chain whenever you want to click a button. So if you want to say, I've got a loaf of bread, it's got lot number 1, 2, 3, 4, 5 on it, what was that made up of, and who gave me those ingredients and sub-ingredients, GSQA produces that. So that's the validation process that you have, in fact, a system that gives you true traceability and product genealogy. And that's how you can, in fact, control first-tier suppliers and second-tier suppliers by the materials you find to be most risky.
Mark or Bill, would you like to weigh in on that?
My only comment was to supplement what John had said is to do this throughout the supply chain, you have to have a common system or standards, and GSQA is one way of doing it that is automated, and it allows you to do it, and you can do it throughout the supply chain. So that's one of the benefits of it. Otherwise, it's got to be standards-based, and that is a requirement as well, but it takes a lot more time as you're pushing it down a supply chain and taking it internationally. So I think that GSQA actually fills the gap that is there much faster.
Okay. And we have a question from Seedclo. And that person is asking, what about manufacturing facilities that opt on relying on suppliers COA or COC? What is your opinion of this culture?
They opt in or they opt out?
I believe they said opted on. Maybe.
This is I think I understand. This is Mark. I think I understand what they're asking.
Okay.
The one thing about COAs or COCs is they're fine if you understand the full complexity of the testing system you're talking about, and you can rely on those certificates of analysis. But there has to be due diligence to understand that the testing fits, understand the methods that are used. You have to understand, again, what those parameters mean, whether it's physical testing that's being done, or pathogen testing, or other types of microbiological testing that are being done. And then the final part of that is you still need to verify through testing what's on a COA at some given statistical frequency. I think blind reliance on COCs or COAs is something that's difficult to do. And in practice, I think you just at some point have to verify that what you're receiving from someone matches what's on that COA or COC. And then you also have to go back and make sure that you're testing in a way that fits the way they're testing, because then you see some non-conformance or non-congruence between test methods. And that's why, again, it's great to make sure you understand the entire testing system and how it affects the acceptance of COAs and COCs.
Okay. Any other comments on that?
No, that's good.
Okay, great. And I encourage our attendees to continue sending in your questions using the Q&A feature. Also, I encourage our panelists to look at their chat windows. And I know that we wanted to talk about this other slide. So, John, I'll ask you to talk about this a little bit.
Yeah, and I did those in my chat. And I see someone asked, can GSQA interface with ERP such as SAP? Most certainly. We have a range of ERPs represented in our customer base. Half of our customer base is running SAP. And we do interface with ERP for a number. We have 14 different data types that we exchange data with ERP. The best example is the purchase order. The purchase order comes down to GSQA, and immediately the quality people know exactly what they're supposed to send, when it's supposed to be due, the quantity, the purchase order number, the ship from, the ship to location. All that information is entered in GSQA automatically via the integration with ERP. But that's one of those nice to have integrations at some point. But the overall value before we leave this presentation is that GSQA and material variability management, which we're focusing on here, is really all about this chart. This is by a quality guru, where he plots the failure cost as you achieve perfect quality, goes down, obviously, but the prevention cost swoops way up as you try to hit perfect quality because it costs a lot to check everything, but nobody can. So GSQA tries to give you the tools efficiently and economically speaking to lower the prevention cost, bring that swoopy line down. If you bring the swoopy line down, it's called prevention cost, then the optimum quality level, big dark arrow, moves to the right. So if GSQA can help you prevent quality issues and lower the cost by putting more and more online, making more and more automated in your manual QA processes, then the optimum quality level moves to the right with not much more expense, if any, and maybe even savings if it's justified correctly, and you improve the overall quality picture in your company and lower the risk of doing business. And that's the good news about implementing a product like GSQA to manage material quality and material variability.
Well, thank you for that, and thank you again to our presenters. I see we are just 1 minute past the top of the hour, and I want to thank everybody for their time today, for coming out and participating. If we did not get to your questions, we will get to them after the event. I want to thank also EMNS for sponsoring this event today. And just if I could ask each of you one final takeaway from this event in maybe 20 or 30 seconds. I'll start with you, Mark.
I think the thing to understand is when you're talking about material variability and safety, that all the things we've talked about kind of fit together, but they have to be managed. I've always said that data in the absence of analysis is just like worth nothing. So, I mean, I think that's the biggest takeaway is these are all steps to helping you provide a good picture of what's going on with things that you purchase and then the safety of them and how you can use them in your processes.
Bill?
My perspective is business is much more or maybe more complicated today than in the past. We have a lot more globalization going on. There is a lot more emphasis on unit pricing and things like that. With that, it's driving a lot more specifications. So it's the amount of information that needs to be managed and managed correctly that companies have to be aware of. And however they do it, whether it's through a GSQA system, which I think is very good, or however they establish integrity in their supplier, their specification, and their purchasing system to manage their supply chain better. Each of these require emphasis and consideration, and it's not going to be something that happens overnight. It's going to require attention and discipline to make it work more effectively to achieve highly successful, safe products in the marketplace.
And John?
Sure. QA, quality assurance, and risk are tied together to be managed, not ignored. Thank you.
Well, again, thank you, everybody. We will be sending out an archive link to this webinar and a copy of the PDF slides in a couple of days. If you have any questions after the event, please feel free to reach out to me at pmurray@innovativepublishing.net. And again, thank you to all of you and to our speakers. Have a great day.